Raffles Girls Primary School Weighted Assessment 1 2025, Primary 5. Okay, for question 1, what is the value of the digit 5 in 750,481? So we look at the digit 5 here. Sorry, you look at the digit 5 here, you realize that it's in a tens thousands place. So our answer will be 50,000. The value of the digit 5 is 50,000. So the answer is 4. Okay, question 2. In which of the following are the numbers arranged from the largest to the smallest? So we look at our option 1. We have 6890 is the largest, followed by 6089, and then followed by our smallest, which is 6809. Okay, so you look at this 6089 and 6809. Okay, 6809 is actually bigger than 6089. So you realize that option 1 is wrong. Okay, now you check for option 2. 6089 is the largest, followed by 6809, and the smallest is supposed to be 6890. Okay, if you look at your largest, 6089 is not your largest, right? Then the middle one, 6809. So this 6809 is really larger than this 6089. So it means your option 2 is wrong as well. Then you look at option 3, your largest is 6890, your second largest is 6809, and then your smallest is 6089. Okay, so this one you look that 6890 is larger than 6809, that is correct, and then 6809 is also larger than 6089. So 6089 is your smallest. So this is the correct option. Okay, so your answer for question 2 will be 3. Okay, but don't just stop there. Okay, do check for option 4 as well. So you see 6089 is the largest, followed by 6890 is the second largest. Okay, so you look at these two numbers, 6890 is already larger than 6089. So option 4 is wrong as well. Okay, let's move on to question 3. 54 is not a multiple of blank. Okay, so if you actually good with your times table, you realize that 54 is a multiple of 9, right? It is 9 times of, sorry, not 9 times of 6. It's actually 6 times of 9, right? Which will give me 54. And then for 6 also, you will realize that 54 is a multiple of 6 because it's 9 times of 6, right? Which gives me 54 as well. Okay? Then if you're good with your times table again, you realize that 54 is also a multiple of 3. It is your 18 times of 3, which gives me 54. Okay, this leaves us with only option 4. So 4 is not a multiple of 54. So our answer is 4. Okay, for question 4, which of the following is equal to 4 and 3 over 5? 4 and 3/5. Okay, so we break down into 4 wholes and 3/5. So for 4 wholes, we convert to how many fifths? So 4 wholes will be 20 over 5. 20 over 5. And then 3/5 is just 3/5. So if we were to add them up, we will get 23 over 5, which is our option 4. Okay, let's move on to question 5. There were 60 books in a class library. 2/3 of the books were fiction books and the rest were non-fiction books. 3/10 of the fiction books were borrowed. So how many books were borrowed? Okay, so we know that 2/3 of the books were fiction books and there was a total of 60 books in the library. So in order to find the number of fiction, will just be taking 2/3 multiplied by my total of 60. So 2/3 times 60. Okay. So how you can do this is you just cancel, right? This 60 and this 3, you can cancel. So 3 will become 1, 60 will become 20. So you're left with 2 over 1 times 20, which will give me 40. Okay. So next, we know we are given that 3/10 of the books were borrowed. So we want to find how many books were borrowed. So to find the number of borrowed would just be my 3/10 multiplied by my number of fiction, which is 40. Okay. So same thing, you can do the cancellation. So the denominator becomes 1, here 40 will become 4. Okay, so we are just left with 3/1 times 4, which gives us 12. So my answer is 12, which is option 1. Okay. Question 6. We're given that Mrs. Wee bought some pies. She gave 2/5 of the pies to her sister and 1/6 of the remaining pies to her neighbor. What fraction of pies had she left? Okay, so if you look at this, she gave 2/5, right? So she gave a part of her pies away and then 1/6 of the remainder to the neighbor. Okay, so this kind of tells you that you need to use your remainder concept. Okay, so we can use the bar model to represent how much pie she had in total. So she gave 2 out of 5 away. So we can cut this bar model here into 5, right? 1, 2, 3, 4, 5. Okay. You know she gave two of these boxes to the sister. So you can just label this to her sister. And what you have here is the remaining or the remainder. Okay. So what happens next? We gave a fraction of the remainder, right? So instead of working with the remainder here, we can do the drop-down model. Okay, so we redraw the remainder below. So now we cut into 6 parts, right? So we can cut into 6 parts. 1, 2, 3, 4, 5, 6. Okay, and then this one part is to the neighbor. I'm just going to put it as N. And then what she have left behind here is just what she has left. Okay. So the question wants us to find what fraction of pies had she had left. Okay. So now we look at the remainder portion. Let's consider this portion of the remainder here together with this remaining portion here that we drew it below. Okay. So you will realize that on the top, the remainder is actually 3 boxes, whereas the one below it is 6 boxes. Okay. So in order to make them the same, we will need to find the LCM of 3 and 6, which is 6, right? The lowest common multiple of 3 and 6 is 6. Okay, so we look at the remaining portion, the one below. There are already 6 boxes, right? So we can just label each as 1U. Okay, and then our remainder, now it's 3 boxes here. So we want to make it into 6 boxes. So it means that each box will represent 2U here. Okay, so you realize that if the remaining portion here is 2U, the rest is 2U as well. So you just fill it in. Okay, and then you realize what you have left is actually 5U. So what you left is 5U. And then your total is actually 2U times 5, right? Which is 2U times 5, which is actually 10U. So the fraction of what you're left over the total will just be 5/10, which actually can be simplified into half. Okay, so in this case, your option will be option number 2, which is half.
By the way, if your child finds this explanation helpful, they can watch more video solutions like this inside the Matrix Math app. These are not just answer keys. Our math specialists explain each question, step by step, using methods aligned with what students are expected to show in school. Many answer keys are too brief, or use shortcuts that students may not fully understand. Inside the Matrix Math app, students can access past year school exam paper solutions from as far back as 2023. Search for Matrix Math on the App Store or Google Play.
Okay, now I'll move on to question 7. So for part 7a, write 5,200,060 in numerals. So 5 million is just 5 with 6 zeros. So 1, 2, 3, 4, 5, 6. Okay, 200,000 is 200, and then thousands is 3 zeros. So 3 zeros behind, and 60. So 60 is just 60. So I want to write this in numerals. So means to write this in numbers. So we add up this 5 million plus 200,000 plus 60, which will give me 5,200,060. Okay, so the final answer will be 5,200,060. Okay, part B. Feel what is the missing number in the box. Okay, so we are given that 103 times 100 equals to 103. So 103,000 divided by blank. Okay, we're supposed to find this value here. Okay, this is the question mark we need to find. Okay, so we work out what is 103 times 100. Okay, so 103 times 100 is just 103. So you multiply by 100. 100 has 2 zeros. So you just write the 2 zeros at the back. Okay. So since my left side will be equals to my right side. So 103,000 divided by blank will also give me the answer of 103,000. Okay. So 103,000 divided by blank will give me 103,000. Okay, 103,000. Okay, so you realize that in order to solve this, so you can imagine 103,000 divided by blank to give me 103,000. Okay, so if you compare 103,000 and 103,000, you will actually realize that you just have to divide by 10, right? Because you divide by 10, you will remove 1 0, which gives me my answer of 103,000. Okay, so the answer in this case will be 10. Okay, next one. What is the value of 20 plus bracket 27 minus 3 close bracket divided by 4? Okay, so we work out what is inside the brackets first, your order of operation, brackets, then followed by your division and multiplication, brackets, division and multiplication, followed by your addition and subtraction. Okay, so first we look out for brackets, which is this 27 minus 3. So we will get a 20. 27 minus 3 will give me a 24 divided by 4. Okay, so since there's no more bracket, next we work out the division and multiplication. So in this case, there's a 24 divided by 4. So 24 divided by 4 will give me a 6. So in this step now, we have no more division or multiplication. So then we can do the addition or subtraction. So in this case, 20 plus 6 will give me a 26. So my final answer here is a 26. Question 9. We're given that ABCD is a square. What fraction of square ABCD is not shaded? Okay, so you look at this square ABCD. Okay, you can see that it's actually split into 4 triangles inside. Okay, so let me highlight the triangle that is split into. Okay, so basically this square is split into 4 of these yellow triangles. Okay, then if you were to look inside this yellow triangle, you see that inside this yellow triangle, it can be further cut into four triangles, right? So this green triangle, this is one of the triangle, and then this green one is another one of the triangle, and then this green here is one triangle, and the lastly is this green. Okay, so actually, if you look, we can cut this figure. So let me show you how we can cut it. Okay, let me erase off this. So in actual, you can actually cut this figure, right? So you cut here, 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 and here. Okay, you will realize that this figure can be cut into 16 triangles. Okay, so our total is 16. And then since we find the fraction of square ABCD that is not shaded, so we count the unshaded. So you count the unshaded, you realize that the unshaded is 11 triangles. Okay, so the fraction of unshaded over the total is 11 over 16. So the answer for this question will be 11 over 16. Okay, next, question 10. Ahmad and his three cousins shared 11 meters of wire equally amongst themselves. How many meters of wire did each of them get? Okay, so we are given that Ahmad and his three cousins, right, shared 11 meters of wire equally amongst themselves. So this shows that Ahmad and his three cousins, so the number of person will be Ahmad and his three cousins, so it's 3 plus 1. So total together, there is 4 of them who are receiving the wire. Okay, we know the total length, or we are given the total length of the wire is 11 meter. So we want to find how many meter did each of them get. So how much will each get? It's just your total, which is 11 meters, divided by how many person you have, which is 4. So 11 divided by 4 is actually just 11 over 4 meters. Okay, this is an improper fraction, so you do not give an improper fraction. Essentially, here you will get 2 and 3/4 meters. Okay, so your answer is 2 and 3/4 meters. That's for question 10. Okay, let's move on to question 11. We're given that Vera had 9 out of 10 kg of flour. She used 3/5 kg to bake cookies and 1/4 of the remaining to bake a cake. How many kilograms of flour did she use to bake the cake? Okay, so for this question, right, you need to be very careful. Okay, so in this case, we are given that the total flour is 9 out of 10 kg. Okay, and then we're also given that she used 3/5 kg to bake a cookie and then 1/4 of the remaining flour to bake a cake. Okay, so please do not be confused by this question because they give you two fractions, right? One is 3/5 kg for the cookies, and then another is 1/4 of the remaining to bake the cake. Okay, so this 3/5 kg is in terms of the value, right? It's an actual value. Okay, whereas this 1/4 is in terms of the units. Okay, so please do not be mistaken between the 3/5 kg and this 1/4, which is the units. Okay, so we're given the total flour. Total flour is 910 kg. Okay, so to bake the cookies, right? We use 3/5 kg. So what is the flour remaining after she baked? She used 3/5 kg to bake the cookies. So the flour remaining will be my total, which is 9/10 kg. Subtract away how much you used to bake the cookies, right? Which is 3/5 kg. Okay. So how we do this is first, we look at the denominators. They are different denominators, so we make the denominators the same. So in this case, 9/10 kg minus, so to make the denominator of 5 into 10, multiply by 2 to both numerator and denominator, so we get 6/10 kg here, which is 9/10 kg minus 6/10 kg will give me 3/10 kg. Okay, next, we want to find how many kilograms of flour did she use to bake the cake, right? So she used 1/4 of the remaining 310 kg. So in order to find how much flour used to bake the cake, will just be taking 1/4 multiplied by your 3/10 kg that is left. Okay, because she used 1/4 of 310 kg. So you take 1/4 times 310 kg. Okay, so this will give you 1 times 3, which is 3, and then 4 times 10, which is 40. So 3/40 kg. So that will be your answer, 3/40 kilograms. Question 12. Anika and Krishnan had a total of 322 at first. After Anika received $74 from her mother and Krishna spent half of his money, they had the same amount of money left. How much money did Anika have at first? Okay, in this question, we're given a before. So in this case, the before is what they have a total at first. So total of 322 at first. Okay, we're also given a change, right? So it means Anika received money. So Anika plus money. And then Krishna spent half of his money. So this is the change. Okay, Anika plus money, Krishna spend money. So Krishna minus money. And then we're given the after as well, or at the end. So in this case, they had the same amount of money. Okay, this is the what you have after. Okay, so when you're attempting this type of question, you need to kind of understand the phrasing of the question. So when when they tell you that after Anika receives $74 from her mother and Krishna spent half of his money, they had the same amount of money left, right? Okay, so this means that after Anika plus money and Krishna minus money, they will end up with the same amount of money. Okay, so from this sentence, you should be able to tell that Anika had, sorry, not more, had less money than Krishnan at first. Okay, so you should be able to tell this. Okay, just let me shift it here. Okay, so if you realize that Anika had less money than Krishna at first, then the next step would be to draw your comparison model. Okay, so Anika and Krishna. So Anika, lesser money, so you draw the smaller box for Anika. And since you know Krishna had more money, so you draw a bigger box for Krishna. Okay? So we are also given the total at first, so you know that the total is actually 322. Okay? But in this case, after Anika plus money, so Anika adds money. So Anika adds money, so you use dotted to represent you add money. So in this case, Anika received $74 from the mom. So you add 74. This is from the mom. Okay. And then Krishnan also spent half of his money, right? So Krishnan, this bar of Krishnan, you need to cut into half. Okay. And this is what he spent. So he spent, you shade away one of the box. Okay. This is how much Krishnan spent. Okay, then in the end, they had the same amount, right? So you check here, here should be the same, okay, same amount. So they should have left with the same. So in this case, what will our total be for this comparison model? In this case, our total will be, if you look at your comparison model, right, you see Anika makes up 1 unit, okay? Then Krishnan also makes up 1 unit. What Krishna had left makes up 1 unit, and what he spent is also 1 unit. And in this case, what will be our total be here? So our total here will be 322 plus how much did Anika receive from the month, which is $74. So this will give us 396. Okay, so our total here is 396. So if you were to look at the comparison model now, we know that we have 396, and this 396 represents 1 unit from Anika and 1 unit from Anika. Let's say, okay, so let me mark it out in the diagram. Here is the 1 unit from Anika, and here is 2 units for Krishna. So you know this 396 represents a total of 3 units. So 3 units is 396. Then you can proceed to find 1 unit, which is 1 unit is 396 divided by 3 to give me 132. So that is for 1 unit. Okay. So after you find 1 unit, you check the question. How much money did Anika have at first? So we're trying to find what Anika had at first, right? So A at first will be, since Anika had 1 unit of money at first, 1 unit of money at the end. Okay, that was after she received $74 from a month. So to find A at first would be taking how much Anika had at the end, which is 132. You subtract away how much she plus, right? Or how much she received. So she received 74, so minus that 74. Okay, you end up with $58. Okay, so that will be your answer for question 12. Question 13. We're given that at a book fair, 210 books were sold on the first day, and then 2/5 of the remaining books were sold on the second day, and the rest of the books were not sold. 1/4 of the total number of books were not sold. How many books were sold on the second day? Okay, so this question tells us we sell some numbers of books on the first day, which in this case we sold 210 on the first day. And then next they tell us that we sold a fraction of the remaining books. Okay, so whenever you have a fraction of a remaining books, this kind of hints or tells you that you probably have to require you to use your remainder concept. Okay, in this case, your remainder model. So how do we draw the remainder model? Okay, so first we use the bar model. We use a bar model to represent how much, or not how much, but in this case, our total number of books. Okay, so for the first day, we sold 210. So we can just cut a portion for 210. This is the first day. Okay, and then what we left at the back here is the remainder. Okay, then after this, we spend a fraction of the remainder. So our remainder here, we can actually redraw it below as well. Okay, and our remainder, we can actually cut into 5 boxes, right? So 1, 2, 3, for five boxes, and then we gave 2 out of the 5 boxes. Not say gave. We sold 2 out of 5 boxes on the second day. So we just mark these 2 boxes out of the 5 boxes second day. Okay, and then the rest of the books were not sold. So this means that the 3 boxes behind is not sold or unsold in this case. Okay, we're also given that 1/4 of the total number of books were not sold. Okay, so our unsold is 1/4 of the total. Okay, that's what that statement tells us. Okay, so how can we solve from here? So you look at what you have unsold, right, which is this one part. And then you look at your remainder model, the unsold here. This is actually 3 boxes, right? So they are not the same. So how can we make this the same? So essentially, in order to make them the same, we need to find the lowest common multiple between 1 and 3, which is 3. So in this case, our fraction 1/4 of the total, we need to make the numerator into 3. So in order to make the numerator into 3, you multiply by 3. So you multiply by 3 to the numerator and denominator, we get 3 out of 12 of the total. Okay? Then you look at what you have left unsold. You already have 3 boxes. Okay? So it means that each box must be 1 unit each. Okay? And this will mean that my remainder is actually 5 units. So now we go back to look at the question. Okay? So not look at the question, we look at our what we have unsold, which is 3 out of 12 of the total. Okay? So this means that 3 out of the 12 parts of the total is unsold. So this means that my total essentially is my denominator, which is this 12. So my total is 12 units. Okay, and since my total is 12 units, I know my remainder is 5 units. How can I work out how many units will this 210 for the sold on the first day represent? So in this case, we take 12 units minus the remainder, which is 5 units. This will give me 7 units. So essentially, this 210 represents 7 units. So 7 units equals to 210. We can find 1 unit by taking 210 divided by 7. Okay, this will give me 1 unit is 30. So from here, since we found 1 unit is 30, you read the question, how many books were sold on the second day? So second day, you can see it's 2 units. So you find 2 units, which is 2 times 30. This will give me 60. So my answer, how many books were sold on the second day, is just 60 books. Okay? Okay, lastly, let's move on to question 14. Natalie bought some packets of potato chips at the prices shown below. So 3 large packets for $8, 4 small packets for $6. She spent an equal amount of money on the large and small packets of potato chips, and she bought 35 more small packets than large packets. Okay, for part A, we're supposed to find the cost of 9 large packets of potato chips. So we're given that 3 large costs us $8. So we want to find 9 large. So we want to find 9 large. So in order to get to 9 large, essentially we have to multiply by 3. So since we multiply by 3 to the left side of the equation, we need to multiply by 3 to the right side of the equation as well. So essentially 8 times 3 will get $24. So the answer for part A is $24 for 9 large potato chips. Okay, so for part B, how many packets of potato chips did Natalie buy altogether? Okay, so in this case, how can we figure this out? So we know that 3 large equals to $8, and we also know that 4 small packets will cost us $6. It will cost Natalie $6. Okay. So the question tells us that she spent an equal amount of large and small packets. Correct? Okay. So this means that she spent an equal money on large and small packets. And we also know that she bought 35 more packets, small packets than large packets. So this 35 represents the difference between the number of small and large. So small more than the large by 35. Okay, since we know we spend an equal amount of money, so how do we make these two equal to each other? So in this case, how do we make the amount equal to each other in that sense? So first, we have to find the LCM between 8 and 6, which is 24. Okay, so the LCM between 8 and 6 is 24. So we have to make $8 into $24 by multiplying by 3. Okay, this will give me $24. So we multiply to 3 to both sides. We will get 9 large equals to $24. And then for this $6 to make to $24, we need to multiply by 3. So you multiply by, sorry, not multiply by 3, multiply by 4, right? Because 6 times 4 gives you 24. So 6 times 4 to give me 24. And then for small, you multiply by 4. So 4 times 4 gives me 16 small. Okay, so since now we have made them an equal amount, right? So we can use something called grouping. Okay, so essentially what do we have inside one group? So let me use the box to represent one group. So we have one group here. We have 9 large, it costs us $24, and 16 small, which also costs us $24. So we use the dots to represent the number of groups. And then in this case, we also know that the question gives us she bought 35 more small packets than large packets. So this tells us the total difference, right, in the number of packets is 35 packets. So since when we know the total difference, we can find the difference inside one group, right? So the difference in one group. So 16 small and 9 large in one group. So the difference between the small and the large in one group is 16 minus 9, which is 7. Okay, so there is a difference of 7 packets in one group. So since we know our total difference, we can find our number of groups. So in order to find the number of groups, essentially it is my total difference, which is 35 divided by my difference in one group, which is 7. This will give me 5 groups. So we want to find how many packets of potato chips did Natalie buy altogether. So altogether means total. So we look at one group, what we have inside one group. How many packets of potato chips do we have in one group? So 9 large and 16 small. So total in one group, we have 9 plus 16, which is 25 packets of potato chips. So in order to find all together, which is the total, so we find 5 groups, which essentially is my 5 times 25 to give me 125 packets. So the answer is 125 packets of potato chips in total. Okay. We have come to the end of the paper.